Hello. Alrighty, so today I'm going to be doing some calculus homeworks because I do have my exam tomorrow. I've done every single one of the homeworks, but I would like to do them again. There's a lot of them, but I would like to do them again just in case if, um, you know, in case if I forget some of these, some of the things, some homeworks and whatnot. So my formula sheet is pretty big. This is my formula sheet, if you can see. So I have that. It's half a page. It's got everything I need for the exam. I don't necessarily think it's gonna be too big of an issue. I don't think I'm gonna use it all the time, but I'm gonna use it if I need to remember like a formula or a specific trig function or whatnot. Also, I'm gonna try to switch from using 4K and going back to 1080p 60 FPS with HDR because of the fact that it is very difficult. I think it took more than 24 hours to upload that 4K 60 FPS video because it was such a massive file. It was 40 gigabytes, so it took more than a day to process, upload, and then kind of like make sure everything was good. Like the way it processed it took way too long. So the 1080p, which is still perfectly fine. Like you see the detail, the background, everything looks really beautiful. It's gonna be perfectly normal for ASMR. Audio system's gonna be perfectly fine. And yeah. So I have a little bit under 40 minutes to do this. So I need to go to my SI meeting afterwards. So I'm gonna try to do as much as I can. Oops. Tycho Brahe. Okay, so if I were to, I don't exactly know where I wrote my, oh there it is, exam review, perfect. So I'm doing 7.1 currently. So if I were to go back, okay, so 7.1, maximize this, or not 7.1, 5.1. Okay, so 5.1, question 53 was y is equal to ln x squared, which is simply doing the ln of that, but then you have to do the inside as well. So doing the ln of the inside, which means that you put that on the bottom. The derivative of the top is going to be another derivative essentially. So it'll become, it goes from ln times ln x squared into 2 over x ln x squared. Okay, so let's go to 50. Okay, I already did 55. Let's do 57. 57 is f of x is equal to the ln of square root of 4 plus x squared over x. Okay, so ln of 4 square root of 4 plus x squared. Okay, this one should be pretty simple. We just need to break it apart. So if we're going to try to break it apart, we need to set one of them ln. We need to, it's a square root, so it'll be 1/2 on the outside. 1/2 ln of 4 plus x squared minus ln of x. Now that is just y. We need to find the y prime, which means that the y prime is going to be the derivative function of this. So 4 plus x squared over 2x, and then the bottom is going to be multiplied by 2 minus 1 over x. So that should be the final answer. 59. Y is equal to the ln of sine x. Okay. I mean, this should be fairly simple. It's an absolute value of sine x, which in reality doesn't necessarily matter. So the y prime is going to be sine x on the denominator and then cosine on the numerator, which means that if it's cosine over sine, then that should be cotangent. So cotangent x is the derivative of ln sine x. 61 is y is equal to ln of cosine over cosine x minus 1. So if we were to write that down, it would be y is equal to, I'm going to move this a little bit, move this towards the back. Y is equal to ln of cosine x over cosine x minus 1. So if we look at our formula, is there a way to see? I don't know if there's a cosine. No, I don't think there is. Like 1 plus cosine minus 1. I don't think there's a rule for that. Okay, I'm gonna keep it like this for now. So this is going to be ln of cosine of x minus the ln of cosine of x minus 1. So the integral, or the derivative, should be cosine of x over, the derivative of cosine is negative sine. And then do I have the formula for that? I don't know if I do. I don't think I do. But I don't think I necessarily need them anyways. If I were to need them, then I would have written them down. Yeah, so negative sine over cosine is equal to that. And then 61. Yeah, so y is equal to negative sine over cosine minus over so cosine derivative of that is again negative sine. So if it's a subtraction, two negative signs equal a plus sign. So there we go. So it's basically negative tangent plus sine over cosine minus 1, which I'm pretty sure sine over cosine minus 1 should be a function. Like it should be one of those, you break it down essentially. But I don't think it matters too much. So if we finish that, so now we have to go to 71. So 71 is logarithmic differentiation. So y is equal to x squared root of x squared plus 1. So x has to be greater than 0. Use logarithmic differentiation to find the dy dx. Okay, this one I believe, I think this is the one where like you are going to set it equals y and then multiply that by y prime, things like that. I'm pretty sure. Let's see. So y is equal to x squared blah blah blah. So then y is equal to the ln of x minus, or actually plus 1/2 ln of x squared plus 1, right? So that's what we know y to be. So then y prime is the derivative of that, which means that it is going to be x over 1, or actually 1 over x, plus x squared plus 1 is going to be in the denominator, 2x is going to be in the numerator, and then this is going to be multiplied by 1 over 2. And then that is the y prime over y. So then we need to take the y on the left side and put it on the right side. So y is now going to be y prime is going to be 1 over x plus 2x over 2x squared plus 2, and this whole thing is going to be multiplied by y, which in this case is x square root of 2x, x squared plus 1. So that should be the correct answer for 71. Going on to 73. I believe we only need to do 3, right? Yeah. So we have 71, 73, and 75. So 71 is already completed. Doing 73 shouldn't be much harder. It's just a little bit of a bigger problem. So y is equal to x squared square root of 3x minus 2 divided by x plus 1 squared. Okay. X has to be greater than 2/3. I don't know if that's necessarily. I think that's for like graphing purposes. So I don't think we need to worry about that too much. So yeah. So moving on, we need to make this in terms of ln. So x squared. So it's gonna be 2 ln of x plus 1/2 ln of 3x minus 2 minus 2 ln x plus 1. Pretty simple. And then the y prime is going to be 2 over x plus 3 over 6x minus 4 minus 1 over 2x plus 2 is going to be y prime over y. But then I'm going to simplify it down because I don't want to rewrite everything. So the final answer should be y prime is equal to this function that we just found multiplied by y, which is its original function. So x squared square root of 3x minus 2 over x plus 1 squared. There we go. That's 73. Moving on to 75. 75 is y is equal to x multiplied by x minus 1 over 3 over 2 over square root of x plus 1. Maybe I'll redefine this, like these ASMRs, by specifying like what homework that I'm working on. So for instance, right now I'm working on chapter 5.1, which is natural logarithmic differentiation. So 5.2 is going to be the integration. 5.3 is going to be the inverse functions, things like that. I think if I can, make it into something like this, it'll be a lot easier. So we did that. I think we're good to go. So let's do 75 really quickly. So we know that y is equal to ln of x plus 3 over 2 ln of x minus 1 minus 1/2 ln of x plus 1. Got it. So then the y prime is simply going to be 1 over x plus 3 over 2x minus 2 minus 1 over 2x plus 2, multiply the entire function by the original, which is x multiplied by x minus 1 to the power of 3/2 over square root of x plus 1. There we go. That should be the complete function for chapter 5.1. So we just finished chapter 5.1 in a very short amount of time, which is very, very nice. So let me check my answers. I would like to make sure that it's correct. So going over to chapter 5.1, which is all the way down here. Okay, so chapter 5.1. It starts from 27. So 27, I think I've already covered 27. We're gonna go to 55. Actually, I think that's where I kind of like moved on. So 55 is 1 over. Oh, I think this one's incorrect. Oh no, it's not. Okay, there's a very slight discrepancy, but I think it should be the same answer. Because they simplified it a lot more than I did. 57 is x squared plus 4. Negative 4 is on the top. Let me see. 57 is the ln of square. So then the ln of that would be 1/2 ln of 4 plus x squared minus the ln of x, right? The derivative of the inside is simply just 2x, so you keep the outside, put it on the, and that should be the correct answer from what I believe. And then 59 is cotangent of x, which, that's true, okay, so it is cotangent of x. 61 is negative tan, okay, that makes sense, plus sine x over cosine x plus 1, which is also correct. Moving on to 71 is 2x squared. Okay, so 2x squared plus 1 over square root. 2x squared plus 1 over. Okay. I think they simplified it down even more. So they just keep simplifying it so much. Let me check my iPad, because my iPad has the legit answers, or I mean they're the same thing, right? But they are simply, these are going to be a lot easier for me to check. So 71 is 1 over x yeah, that looks to be correct, and then that one perfect. Okay, so I was correct. I was a little bit panicked, a little bit worried that it was not correct, but lo and behold, we are good to go. Okay, so that was chapter 5.1. Chapter 5.1, we had multiple ways to find the differentiations of these logs, and yeah, they look fairly simple, And then there's also the ones where I'll write it in the corner. It's like y prime over y is equal to y. So then this y prime over y, and then this turns down to y prime is equal to times the y. And that's connected to 5.1. Okay, so I wrote that down just in case. So let's move on to 5.2. 5.2 should be the integral. So the integration of 5.2 is the integration. So we only have a couple problems from 5.2. So it's 5 to 27 odd. So let's get them quickly. I have roughly 15 minutes to complete these. So, or 25 minutes. Yeah, 25 minutes. So let me put these down really quickly. So chapters 5.2, let's go to number 5. So the integral of 5 over x dx is simply going to be, you take the 5 on the outside, it's going to turn to 1 over x, but then if it's 5 on the numerator, so if it's a constant on the numerator, you should be able to just set that equal to 5 ln, and then the ln is going to be x plus 7. So that was 5.2, right? Okay, perfect. So that's 5.2. 7 is going to be the integral of 1 over 2x plus 5. So 1 over 2x plus 5 is going to be, this one's pretty simple too. It's just going to be ln of 2x plus 5 plus c, I believe. I don't think you need to do anything. Let me make sure, because I'm a little bit worried of how easy this is. Oh, okay. No. Yeah, it's not. You can't just do that, right? Yeah, you can't just do that. Okay, there's a slight deviation. So you can only do something like what I did in the first one, which is 5 ln of x, because of the fact that there is a single variable in the denominator. So yeah, in order to solve for 7, or integrations in general, we need to start applying the u substitution. So u is going to be 2x plus 5, du is going to be 2x, or sorry, du is just going to be 2 dx. So if that's going to be du, what that means is the integration is going to be 1 over u, and then 2 is going to be, it's going to be 1, so it's going to be du over 2, which means that I can take that 1/2 out, and it'll be 1, so that 1/2 integral of 1 over u, or 1 over u times du, which in this case would be 1/2 ln of 2x plus 5 plus c. Going over to 9 is going to be the integral of x over x squared minus 3 dx. So x over x squared minus 3 dx is going to be another u substitution problem where u is going to be the denominator from what I'm assuming. And remember, whenever doing these like integration problems, I think it's okay to pick, like, using your educated guess to pick which one is, you know, going to end up being the u substitution. But it doesn't really matter, because if you do get it wrong, which sometimes you know, of course you'll get it wrong, you can just change it. Just pick the other one, or pick another one. So u is equal to x squared plus minus 3. Du is going to be 2x dx. So this is good because it's going to cancel the x out. So then we're going to have 1/2 on the outside. There's going to be 1 over u, and yeah, that's it. So 1 over u is going to be the, so just like that, we now know that it's going to be 1/2 ln of u, but in this case u is x squared minus 3 plus c. Going over to 11, and I'm going to check all these afterwards, so I'm good to go there. So 11 is going to be the integral of 4x to the power 3 plus 3 over x to the power 4 plus 3x. And then this whole thing is like multiplied by dx. So what is u in this case? U is going to be the denominator, because I can see the greater powers on the denominator, so I can immediately tell that it's going to cancel out the numerator. So u is going to be x to the 4 plus 3x. du is going to be 4x to the power 3 plus 3 dx. So that's immediately going to get rid of the numerator, which is perfect because we're left with 1 over u du. And then what is that? Well, that's going to be the ln of x to the power 4 plus 3x plus c. 13 is x squared minus 7 over 7x dx. Okay, so for this one, let's see. So for this one, another u substitution. Let's see. If we apply the denominator, it looks like the u sub might have to be the numerator because it breaks down. Du is going to end up being 2x, which means that it. No, it doesn't make sense. I think u still needs to be 7x because it needs to end up canceling out the numerator. Or maybe this is one of those annoying problems where you need to do like a plus 7 minus 7 or something like that. One of those annoying ones. Well, let's see. So this is number 13. So u, let's just say, if we say u is equal to 7x, du is going to be 7. Sure, it's going to cancel that out, but we're still left with an x squared. That's not going to help our situation. But if we use numerator as x squared minus 7, then we're going to be left with 2x on the denominator, or 2x as the du, which means that it's going to be du over So it'll be u over 7x times that, which does not necessarily make sense either. I think we need to separate this into two different integrals. So this is my guess is that we can separate this because it's a subtraction. You should be able to separate these integrals because it has a single denominator. So what we can do is the integral of x squared over 7x is going to be subtracted by the integral of 7 over 7x. So for this, for the first integral, u is going to equal 7x. No, I think u has to equal x squared. Du is equal to 2x dx. So then, if that's the case, then we can apply that du over 2x, and then it's going to cancel that out, and then put that as x. And then, wait, actually, that doesn't make sense because, I'm a little bit confused now. Okay, let's see what I did. I'm gonna cheat a little bit. Oh, what? That was a very specific solution. So it was very similar to what I did, where I separated those two integrals. So I was correct in the fact that you were supposed to distribute them into two different integrals, but you also need to take out the 1. You also need to take out the 7 on the denominator, which means that it's going to be multiplying 1/7 to the entire integral. So 1 over 7 is going to go on the outside. X squared over x minus, well, the integral of x squared over x minus the integral of 7 over x. So in this case, if it's x squared over x, isn't that just like x? Let me see. How did that go from x dx? Okay, so I think u substitution will be x squared, so x squared du is equal to 2x dx. So it's going to be du over 2x is equal to dx, right? So then u is equal to x squared, so if that's going to be u, it's going to be over, what? I don't think that doesn't make sense either. What? X squared, the integral of x squared over x is, okay. Yeah, I overcomplicated it. So it's just gonna be x squared over x, which is simply dividing it on top of each other, which means that it's gonna be x. So x, the integral of x is simply x squared over 2. And then we're gonna subtract it by the integral of 7 over x, which means that it's just gonna be 7 ln of x. 7 ln of x, which means that this whole thing's gonna be multiplied by 1 over 7. So in the end, it's gonna be x squared over 14 minus the ln of x, because it simplifies. That should be the correct answer. Yup, there we go. Plus c. Wow, that's a very interesting problem. So when it comes to integration, it's also possible to take out the denominator so that you can separate the variables. Separate the integration, and then you also need to take out the constant from the denominator. 15. So 15 has the integral of x squared plus 2x plus 3 over x to the power of 3 plus 3x squared plus 9x dx. Okay, so right off the bat, I think yeah, I think the u substitution should be the denominator. So if u is equal to if u is equal to x to the power of 3 plus 3x squared plus 9x, du is going to be 3x squared plus 6x plus 9 dx, which means that we should be able to cancel out some of them, right? We should be able to cancel out some of the x's. We're not going to be able to perfectly cancel them out, but we should be able to cancel a decent amount. So in essence, it should be x squared plus 2x over u, and then we're going to multiply that by du over 3x squared plus 6x plus 9, which means that we can cancel the x squared, sure. We can take out the x here, and then put that, oh, I don't think that's possible, never mind. I don't think we could just simply, just do something like Okay, so, let me think. I can see that we can take an x out from the denominator. Okay, so I think what we can probably try to do is to set the denominator so that we can take out an x, which means that if we take out an x, it will turn into x squared plus 3x plus 9, and then find the derivative of that, which would be 2x plus 2x squared. No, it would just be 2x plus 3. 2x plus 3, which would cancel that out, and then we'll be left with an x. Okay, this one's confusing as well. What? How am I having difficulties? Oh my god. Okay. So looking at the du, we can actually take out a 3, which would turn that into an x squared plus 2x plus 3. So then we cancel that out. So then the integral would be 1/3 the integral of du over u, which means that it's going to be 1/3 ln of u, which is the denominator, ln of x to the power of 3 plus 3x squared plus 9x plus c. That should be the correct answer. Yep. Okay. So it's good that I'm refreshing myself, because it would have been really frustrating to try to do this on the exam. Okay, so I have 10 minutes until I have to go to my SIME. So so that's 15. This is 17. So 17 is the integral of x squared minus 3x plus 2 over x plus 1 and then dx. Okay, so u is going to be let's just try the numerator as u. So u is equal to x squared minus 3x plus 2. Du is equal to 2x minus 3 dx. So then it's going to be the integral of u over x plus 1 times du over 2x minus 3. That's not going to work out properly, so we can't really do that. Um, oh, okay, so I think that's a, from what I'm seeing, that looks to be a square, so like, I think -2 and -1, right? So I think if it's x plus 1, x minus 2, I think. So then first x squared plus, no, it's gonna be minus x squared. So x minus 1, x minus 1, and then x minus 2 should form. So then the first one is gonna be x squared. First, outer, inner, and then last. Perfect. So then it will turn. Okay. So now that we have something that's broken down, we can set u is equal to x plus 1, and then there's a piece of the puzzle that I'm not understanding. X squared minus 3x plus 2. That makes sense. Denominator is x plus 1. Okay, so u is supposed to be okay. I mean, u should be the denominator. But then if the u is the denominator, it's just going to be 1, correct? So how is 1 going to help in this situation? Oh, I think I figured it out. So we turn that into a perfect square, right? So if I think we could separate the integrals. I think it's possible. And then multiply that by the integral of x minus 2 over x plus 1. So if that's possible, u sub would be x plus 1, and then it's going to be du over 1. Still doesn't make sense. What? Okay. How am I forgetting this stuff? This is not good. Or am I even supposed to do these problems? Yeah, I'm supposed to do that. 5 to 27 odd. Is this the 5 to 27? Yeah, so 15 is not correct. That's correct. Oh, wait, 17 is gonna be 5.2, right? Oh crap, I need to put that in my equation. We have to apply the long division for integration. Ah, my god. Okay, so 5.2. I'm gonna put a lightning symbol, and then the lightning symbol down here. So for some. Long division for some integration. Okay. This makes a lot more sense. I have 4 minutes to solve this problem, which is not good because actually no, I should be able to solve it in 4 minutes. So now that I know that it's long division, what I could do is set x plus 1 as the divisor, and then I believe the dividend is x squared minus 3x plus 2. So if that's the case, if we just apply a simple x times x is going to be x squared, and then times another x is going to be x. So we subtract this, we get 0 here, and then we get a negative 3, or actually it'll be a negative 4x. So if we put a minus 4, it's going to be minus 4x minus 4, right? So this is going to turn that into a positive, so this turns to 0, and then that turns into a positive, so we are left with the integration of x minus 4 plus 6 over x minus 4, or 6 over x plus 1, I think. Yeah, 6 over x plus 1. So if that's the case, is that the final answer? I don't think that's the final answer, right? Yeah, we still need to integrate it. So the integration is going to be simple. X will be x over 2 over 2, or x is going to be x to the 2 over 2 minus 4x plus, and then it's going to be 6 times x minus x plus 1 to the negative 1. So the integration of this is simply going to be, we're adding 1, right? Oh my god, I keep getting confused over these ones. Oh yeah, you can't really do that. So what you can do instead, really? You can do that? Well, why couldn't I do it on the other ones? Oh, okay. So, in order to, some of them you don't even need to use substitution. If you can isolate the x without, if x doesn't have a coefficient, then you can just use the ln function. So 6 over x plus 1 does not have anything in front of the x on the denominator. So what you can do is put 6 and then ln of x plus 1 as that. Well, see, that's useful. I forgot about that. That's very, very useful to know. And it's 15. So that wraps it up. I think I'm going to try to do some more tonight. I'll have more time tomorrow as well. So I have a decent amount of time to complete all this stuff. So I really, really enjoy learning these things again because it's helpful for the test. So I hope you guys enjoyed the ASMR. You should be asleep by now. If not, then hopefully you can watch one of my other videos to go to sleep. But yeah. So today we worked on 5.1 and almost finished 5.2. So yeah. All right. Thanks for watching. See you guys later.